Alright, hey everybody. Welcome back. I am going to run through the two questions on the second practice exam here. So we've got the answer keys here. I've already posted it over on Canvas. I'm going to kind of edit and annotate a little bit as we go through this. Alright, so this is question 1. It says, Daniel believes that people perform better in the barbell curl on average if they are encouraged by a coach. He recruited 29 subjects to participate in an experiment and randomly assigned them into two groups. Daniel gave one group verbal encouragement during the exercise and was quiet during the exercise for the other group. He recorded the total number of barbell curls each subject was able to complete before setting the bar down. Alright, so explain the purpose of random assignment in this experiment. Alright, so this is going back to Chapter 4 notes and just why we do random assignments. This is the type of question I think that you are more likely to get on this exam. Digging into the whys and hows as opposed to here, crunch these numbers and tell me what it means. So in this one, the purpose of random assignment is to create two groups of subjects that are roughly equivalent in their ability to do barbell curls at the beginning of the experiment. And this will allow for a cause and effect conclusion if the difference between two groups is statistically significant. You might mention how you want to have a control group versus a not. You could throw that in there and just to give better comparisons as opposed to just having one group so you have something to compare to. More often than not, though, with these questions, you want to be quick. You want to get in, you want to get out. All right, so don't elaborate. Don't write for 3 paragraphs for this question. Couple sentences, boom, move on to the next one. All right, so we've got here box plots that summarize the distribution of number of barbell curls for each group. Compare these distributions. All right, so this is coming out of Chapter 1, and then this is our Visco or socks. And as you go through, you're going to see they hit all of those. They don't do a separate sentence. They do combine them together, but they're showing them. And the one thing you want to do when you are comparing two distributions is you want to make sure that you're talking about whether one is bigger than the other. And you'll see as we go through this answer, but make sure that when you're talking about centers and spread and things like that, you're using them in relation to each other. Remember, the other thing you want to make sure you have in there is context. So it's Visco or socks plus context. So you got to make sure that you get in there somewhere that we're talking about barbell curls. All right, so the distribution of number of barbell curls is slightly skewed to the right for both groups, with more skew in the distribution for those that weren't encouraged. All right, so they've gone through there. They talked about how the one group has a larger skew than the other, and so it's comparing the two of them. So make sure you're getting that in your answers. The median number of curls and the variability in the number of curls is greater for the group that received encouragement. All right, so that was center. They talked about median. And then variability, they're talking about spread. And then neither distribution has any outliers. So if you notice, nowhere in there did they do numbers. They just compared the two, and that is completely accurate and that are acceptable. That works. So just be careful with that. If you get explicit numbers or you can read explicit numbers off of the graph, go for it. In this one, the scale is going up by tens. That's going to be kind of difficult to estimate. So if not, just go through and do your comparisons and move on. All right, and they got each one. So they talked about the shape in the beginning, then they did a center and spread, and then outliers was the very last thing. All right, state the hypotheses Daniel should use to test his belief about receiving encouragement during exercise. Make sure to define any parameters you use. So the one thing I do want to throw out here is we've been using subscript numbers, and that is actually more acceptable this year. So this would be completely fine, but you have to make sure you say what mu1 and mu2 are. So make sure that you label these somewhere along the way. You can write it as a sentence. Oh, sorry. You can write it as a sentence. You could write it like this off to the side. mu1 is this, mu2 is this. Just make sure that you're labeling. All right, so we've got these two hypotheses here. And then saying identify the significance test. All right, so we are comparing two things together, and we are talking about the average, the mean. So we're going to be using a two sample t-test for means, or for mu1 minus mu2. All right, so for our conditions, we're random, normal, large sample. So for this case, it is, since it's means, we're talking about large sample. So first would be that they said it was they would say that it was a normal distribution. They did not. Then we would have to have a sample size bigger than 30, which we do not. So the last option is to look at our graphs and see if we have strong skew or outliers. So we had some skew, but we don't have really strong skew, like really hard, everything slammed to the right or everything slammed to the left. And so that's why we can go ahead and do this. All right, and then the p-value for Daniel's test is 0.107. What conclusion should he make at the alpha equals 0.05 significance level? I do think you are going to have to answer one of these questions on your exam. I would be shocked if you don't have to go through and make a judgment call based on a p-value. And in this case, 0.107 is larger than 0.05, so Daniel's going to fail to reject the null hypothesis. You do not have convincing evidence that people like the ones in the experiment can do more barbell curls on average when they have encouragement. So make sure when you're saying yes or no on the concluding evidence or convincing evidence that you are using some of the verbiage they use. So when they receive encouragement, that's something that they said back up at the beginning of the problem. So make sure you use some of their wording. All right, cool. So that was question 1. Let's take a look at question 2. All right, this one, here we go. So this was the one about napping. So long-term study of 3,462 randomly selected adults from Lausanne, Switzerland. Researchers investigated the relationship between weekly napping frequency and whether or not a person experienced an event related to cardiovascular disease, such as a heart attack. And the two-way table summarizes the data. All right, so we're pretty familiar with two-way tables. We've been using them fairly regularly. So it's yes or no that they had an event, and then comparing that with how many naps they had per week, not per day, so per week. All right, so in the sample, 4.5% of people experienced a CVD event. To what population can this result be generalized? And explain your answer. All right, so this actually comes from chapter 4 again, back when we were talking about designing our experiments. So we pulled adults from the population of Lausanne, Switzerland. So that's all we can talk about. We can't extrapolate this to all adults in the world. We're just pulling it from the people in Lausanne. All right, one person from those surveyed will be selected at random. What's the probability that the person selected will be someone who reported taking at least 3 naps per week? All right, you can leave your answer as an unreduced fraction if you want. Looks like they gave us both answers here. All right, so probability the person selected will be someone who reported taking at least 3 naps per week. So for naps per week, oops, sorry, that is this column and this column together. So that's why they were adding them together. So it's 411 plus 370. So that's our 3 to 5 person, and then our 370 is our 6 to 7 naps per week person out of the total population. So 781 divided by 3,462, they're saying they would take that answer, or if you actually do the division, you get about a 22% chance. What's the probability that a person selected will be someone who has experienced a CVD event, given that the person reported taking at least 3 naps per week? All right, so we're looking at the same columns, except now we're looking at the yeses. So there were 22 people of the 3 to 5 naps per week that experienced a CVD, and then 28 people from the 6 to 7 naps per week. And that's out of the total number of people that took 3 or more naps. So that's where that 781 came from. And then again, just dividing that out, we get about a 6% chance. All right, let PF equal the proportion of people who have experienced a CVD event among those in the population who would report frequent napping, which is at least 3 naps per week. and let PI equal the proportion of people who have experienced a CVD event among those in the population who would report infrequent napping. So 2 or fewer. A 95% confidence interval for PF minus PI is 0.0062 and 0.0435. All right, one condition for constructing this confidence interval is that the number of people who experienced a CVD event and the number of people who did not experience a CVD event in each of the two groups is at least 10. Why is it necessary for this condition to be satisfied? All right, so the 10 condition, that is dealing with approximately normal. All right, that's our large count, so it has to be bigger than 10. So you have to go in and say why. That's all they're asking there. All right, and then interpreting that confidence interval, I hope you get to interpret, because we've got that one down. You've got it in your notes. We're 95% confident that the interval from 0.0062 to 0.0435 captures the difference in the proportion of people who have experienced a CVD event among those in the population who would report frequent napping, and their proportion of people who have experienced a CVD event among those in the population who would report infrequent napping. That would be sufficient. Like, that is a complete answer. On the other hand, you could say it a different way, like they do in the second sentence, and as long as you go in and make sure that you talk about infrequent versus frequent napping, you could also write it this way. So in other words, we are 95% confident that the proportion of people who have experienced a CVD event is between 0.62 percentage points higher and 4.35 percentage points higher for frequent nappers. I would leave it as the first sentence rather than the second. To me, that's a little more convoluted. All right, even though all values in the confidence interval are positive, a cause and effect relationship between napping and CVD cannot be established from the study due to possible confounding. Identify a potential confounding variable in this context. Justify your answer. All right, so pulling back from chapter 4 again, confounding variables are the ones that can mess up your data and you don't realize that it's there. So one thing they're throwing out as a possible confounding variable could be age, saying that age could be related to napping and CVD. Like, older you are, the more likely you are to have a cardiovascular event, but also could be that the older you are, the more opportunities you have to nap, or less opportunities to nap. Because if you could talk about children into this as well. They seem to be focusing on adults, but you could throw, young kids in there as well. So it just depends. All right, so when you're doing confounding variables, you got to make sure you say what the confounding variable is and how it could be affecting the results. So make sure that you give both of those pieces for full credit. All right, fam. So this is the last one for the last question for last week's. I have already gone ahead and posted 2 more for this week and next week. I just went ahead and put them up, figured you could work through them at your own pace. All right, if you have any questions, let me know. We've got office hours, and then the review sessions will start kicking in soon.